All right, we're back with 5, 8, 9, and 10 from your algebra. No, not algebra. That's wrong. Geometry, Chapter 10, practice test. We got number 5 on the screen here, where we have some identical small cubes of side x centimeters packed into a cubical box with no space left over. Sounds exciting. There are 7 layers of small cubes in the box. What is the volume of the box? So this is the large cube, okay? And then within this cube, there is a series of smaller cubes. And each of those smaller cubes are x centimeters long. So that means along this width here, there are 7 cubes, and each of those cubes are x centimeters. So that means that the length of this side is 7x, because there are 7 cubes of x centimeters. So there's a distance of x, 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 x 7 times, and therefore that width or length, whatever you want to call it, is 7x. Subsequently, all the other sides are also 7x because it's a cube. And we want to find the volume. Well, the volume of the rectangular prism, or the cube, or the box, whatever you want to call it, is the length times the width times the height. So we're going to take these 7x's and multiply them together. 7x times 7x times 7x, which gives us 343, because 7 times 7 times 7 is 343, times x to the 3rd power. And that is our volume of this box. Number 8, a cylindrical oil storage tank has a height of 19 meters and a diameter of 18 meters. If the tank is 50% full, that's half, how many kiloliters of oil to the nearest tenth does it contain? And we're going to use 3.14 for pi, and they also tell us that 1 kiloliter is equal to 1 cubic meter. So the first thing I'm going to do is I need to know the volume formula for a cylinder. And the volume formula for a cylinder is the volume is equal to the area of the base times the height of the cylinder. Again, the capital B stands for the area of the base. In a cylinder, the base is a circle. So I'm going to find the area of that base. Pi, I'm using 3.14 for pi because we are told to use 3.14 for pi, times 9 squared. 9 is the radius of the cylinder, or of the base of the cylinder, because it tells us that the diameter is 18 meters. 9.5, where does that come from? 9.5 is the height, but looks like over here the height is actually 19. Yes, it's 19, but they're saying that the cylinder is only half full. So I'm just going to find the volume of half of this cylinder, since only half of it is being filled up. Once I have this, I'm just going to do the order of operations here. I'm going to do 9 squared. 9 squared is 81. And then I'm going to multiply all these things together. And I'm going to find that the volume is equal to 2,416.2 meters cubed. But they want it in kiloliters. I have meters cubed because all these measurements here were in meters. So I have to refer to the translation here, or the conversion. 1 kiloliter is 1 meter cubed. Oh, well, that's easy. If 1 kiloliter is 1 meter cubed, then really that is the same answer. And the answer will be the volume, if this tank is half full, is 2,416.2 kiloliters. Number 9, Pallas is an asteroid with a circumference of about 3,579.6 kilometers. And we're going to assume that Pallas is a perfect sphere. Okay? Perfect sphere. And we're going to calculate its surface area to the nearest square kilometer. And we're going to use 3.14 for pi also here. So we have this perfect sphere asteroid. And we're going to find the surface area. So we need the surface area formula. Surface area formula for a sphere, because it's a sphere here, is 4 times pi times the radius squared. Okay, so I need to know the radius. What's the radius? Pallas is an asteroid with a circumference of about 3,596.79.6 kilometers. I don't see a radius here. They don't tell us a radius. So we must not be able to do this. Oh, we are able to do this because they tell us the circumference. And if we know the circumference of a circle, we can find the radius because the circumference of a circle is equal to 2 pi r. And I know the circumference because we're told that. It's 3,579.6. That is got to be equal to 2 times 3.14, because I'm using that for pi because I'm told to do so, times the radius. Now I can solve for the radius by using algebra. I know what 2 times 3.14 is. It's 6.28. I've done that a lot of times. So I have 3,579.6 is equal to 6.28 times r. So to solve for r, I'm going to divide both sides by 6.28. And you know what that is? It's 570. Pretty neat how that works out perfectly. So 570 is the radius. But we're not even close to done because they want to know the surface area, not the radius. Why did we spend all this time finding the radius then? Because we need that to find the surface area. So now I can take this radius and plug it into our surface area formula for a sphere. So once I plug that in, this is what I get. Where does this come from? It comes from the radius. I found the radius and I'm plugging that radius into the surface area formula. And now I just have order of operations to do. And notice once again I'm using 3.14 for pi because I'm told to do so. Use 3.14 for pi. So I'm going to do this math here and I get 324,900. That's 570 squared, by the way. Surprised you didn't know that. And now we're going to multiply these things together. And this is all done with the calculator, folks. I don't know what 570 squared is. Come on. 3,000, or I don't even know how to say it, 324,900. So I'm going to multiply these things together to find that surface area. And that surface area is going to be 4,080,744 kilometers squared. There's your surface area. And notice it's in kilometers squared because area is units squared. This is our answer right here. That's how big that asteroid is. It's pretty big. Pretty big asteroid. And number 10, Toys Aren't Cheap is featuring a new ball made of a foam outer shell and a rubber inner core. This is much like an earlier problem. I think it was number 5, something like that. The radius of the entire ball is 17 centimeters and the radius of the core is 13 centimeters. What is the volume of the outer shell alone? So now we're given numbers. So this is going to be a little bit easier because we're given numbers. Now we're going to actually get a number for our answer because we're given values for the ball. We know how big the ball is. So the first thing I'm going to do is find the volume of the whole sphere, the whole ball with everything, the core and the shell all combined. That is what this is, the volume of the entire sphere. Once I do that, I'm going to find the volume of the inner core. That core there, I'm going to find the volume of that because I'm taking that out. That's not included in the shell. So I'm going to evaluate these two things. This looks like a mess, but we can still evaluate it. Just do it a step at a time. So I'm going to do the volume of the outer shell is going to be the volume of the entire sphere minus the volume of the inner core. So I'm going to subtract those two things. So this mess right here is the volume of the entire sphere. This 4,913, that's 17 to the third power. The pi gets changed to 3.14 because we are told to use pi equal to 3.14. This right here is the volume of the inner core. 2,197, that's 13 to the third power. And the pi changes to 3.14 because we're told to do that. Once I do this evaluation, once I do 4,913 times 3.14 times 4 divided by 3, get a value for that. It's about 20,000 or something. Do the same thing over here. 2,197 times the 3.14 times the 4 divided by 3. I get some value for that. It's about 9,000 something. I'm not sure exactly what that is. You can check all that stuff with the calculator. Once we get those two values, we subtract them. That's what we're doing. And when we do that subtraction, we get 11,371 centimeters cubed. And this right here is the volume of the outer shell because I took the volume of the whole sphere and I'm subtracting the volume of that core because it's being taken out and not included in the outer shell.